Now we come towards the instruments to measure the pressure. Normally it is barometer, a manometer, and barometers will be classified into two categories, like one is called the aneroid barometer and other will be the mercury barometer. Our main discussion will be on the mercury barometer. So we are referring a concept here. Barometer means barometer stands for, like we are recording the pressure in bar. Torricelli devised this instrument to measure atmospheric pressure. In this, a glass tube is completely filled with mercury and dipped into mercury-filled beaker with its open end inside mercury. The upper part contains vacuum as the mercury goes down and no air is allowed in. The pressure at point A, that will be 0. So, in a mercury barometer, the upper point is a vacuum. A is the point where the mercury will rise and the meniscus of mercury will be concave. The mercury level will move up to height h. As point B and C are in same horizontal level, so PB is equal to PC, which is equal to atmospheric pressure P0 at that location. Suppose B is at depth h below A, so PB, that is equal to PV plus rho GH. When we write this equation, basically we are saying that pressure is HdG. D stands for density. Here we are taking density as rho. So rho is the density of mercury and P0 will be rho GH. Now comes the manometer. Manometer is a simple device to measure the gauge pressure of fluids. It consists of a U-tube having some liquid. One end of the tube is open to the atmosphere and other end is connected to a vessel of which we have to measure the gauge pressure. So, pressure at A will be equal to pressure at B as shown in the figure. So, it is a U-type tube, U-shaped tube, and B and C are the 2 points. Height is h. That is, the mercury will rise up to that point. So, pressure at C plus rho GH will be pressure at A. It can be written as P0 plus rho GH, or delta P is equal to PA minus P0 is equal to rho GH. Now comes the buoyancy. To understand buoyancy, we will make the body to float in water. When body is kept on the surface of water, the body will exert pressure on the surface of water downward, and then liquid will exert pressure in the upward direction, and that is called buoyant force. So, if a body is partially or wholly immersed in fluid, it experiences an upward force, that is upthrust, due to fluid surrounding it. The phenomena of force exerted by fluid on the body in the upward direction is called buoyancy, and the force is called buoyant force. So, buoyant force is within the liquid, and it is the force acting on a body in the upward direction exerted by fluid or the liquid. When solid body is immersed in liquid, it displaces the liquid partially or completely of its own volume. So, liquid displaced by the solid will be equal to its volume. That is the law of flotation. While going so, it pushes or applies a downward force on the liquid. Hence, in accordance to the Newton's third law, that is action and reaction are equal, the liquid also exerts an upward force equal to the weight of the displaced liquid, and weight of the displaced liquid will be mg and mass will be density into volume. Volume is area of cross section into height. Now we come to the Archimedes Principle. That is, Archimedes Principle states that when a body is partially or fully dipped into a fluid at rest, The fluid exerts an upward force of buoyancy equal to the weight of the displaced liquid. So in the earlier portion, I have explained that whenever body is partially or fully immersed, there will be a buoyant force acting on the body, and that is equal to the weight of the displaced liquid, and that is what stated by Archimedes. If V is the volume of displaced fluid of density rho, then buoyant force will be FB, that is V rho G, where V is the volume. Volume is area of cross section, area into length. Buoyant force arises because of the pressure in the fluid is not uniform but increases with depth. Buoyancy force acts through the centroid of the displaced fluid. Buoyant force may be different from the weight of the displaced fluid in non-inertial frame of reference. Non-inertial frame, where we don't expect any mass. Now comes the laws of flotation. The law of flotation, I have just spoken that when a body is fully or partially immersed, the buoyant force will act on the body. It is the upward force. If the upward force is slightly less as compared to the force acting on the body begins to float. So the main concept is when the force of buoyancy is equal to the weight of dipped, partially or completely solid, the solid will remain in the equilibrium position. This is called flotation. When overall density of the solid is smaller than that of the fluid, the solid floats with a part of it in the liquid. The fraction dipped in is such that the weight of the displaced liquid equals to the weight of the solid. Apparent weight. A solid of volume Vs is dipped inside a liquid where it displaces the liquid by volume Vl. If rho S and rho L be the density of solid and liquid respectively, then apparent weight of the solid is. So apparent weight is taken as Vs rho S G minus Vl rho L G, where rho S means density of solid and rho L means that is density of liquid. So apparent weight is Vs into rho S minus Vl rho L G. For completely submerged solid, if it is fully submerged in liquid, then Vl is equal to Vs. That is volume of liquid displaced is equal to volume of solid. And we have Wa, that is the apparent weight is equal to Vs into rho S minus rho L into G.